All right, guys, it's November 5th. You guys have school off tomorrow for the election, and I am going to attempt to start the homework with you, 2.2 A and B, in order to give you, like, feeling somewhat good. Maybe you don't feel 100%, but you feel somewhat good. Okay. If you're confused at all, I would recommend 2.2A. If that seems overwhelming to you, that's just some basics. If the inequalities are getting to you or whatever, you can skip that. But you should feel pretty solid about 2.2B. I'm going to get you going on 2.2B, question A. Okay. Length of pregnancies. The length of human pregnancies from conception to birth varies according to a distribution that is approximately normal, with a mean of 266 and a standard deviation of 16. At what percentile is a pregnancy that lasts 240 days? Okay. Again, it says at what percentile. So you're going right now with this stuff here. What percent, what proportion? Draw your picture first. So I'm going to draw my picture, and you can see I put it down here. I put my mean of 266 in the center, my standard deviation of 16 right here, and then the observation of 240, and finally I shaded. Okay, what percentile by definition is always less than? Okay, so I shaded to the left. Go back. Next thing, find a z-score. That's ZOMS. Again, pause where you need to. So if I scroll down here, you can see that I have ZOMS. Gotta get rid of this here. And I did my observation minus my mean divided by my standard deviation to give me negative 1.63. This is the only time when I want two decimal places. Okay, now what do I need to do? I need to go to my table at negative 1.63. Now remember, if you go to your summary from yesterday, table A is the outside, okay, when we're dealing with the what percent or what percentile, what proportion. So I go to the outside of my table. Negative 1.6 is right here. And then 3 is right here. And you have to see where they intersect. And it looks like they intersect right here at 0.0516. So you can answer it as 5.16 percentile or 0.0516 as a proportion. I don't care. Either one, I will give you credit. That hopefully gave you a good start on number 53. 53B is very similar. The only thing that's different is it's a between problem. Okay, so this is from Friday notes. I want you to try 53B on your own now. I don't want to do all of them with you. I just want to give you a start. Number 59, the decils of any distribution are the points that mark off the lowest 10% and the highest 10%. The decils of a density curve are therefore the points with a 0.1 and a 0.9 to the left under the curve. What are the decils of the standard normal distribution? This is just wondering what are the z-scores that go with the lowest 10% and the highest 10%. I'm going to skip that for now and just go straight to part B. Okay, part B says the heights of young women are approximately normal with a mean of 64.5 and a standard deviation of 2.5 inches. What are the deciles of the distribution? Well, we know that deciles, because it just told us, is the lower 10% and the upper 90%, or upper 10%, excuse me. The summary from today or yesterday, depending on when you're watching it, when you are given a percent, still draw a picture, okay? So I'm going to draw that picture. And I have 64.5 as my mean, my standard deviation at 2.5, my upper 10%, and my lower 10%. Okay, that's my picture. Then what does it say to do? Go to table A, but now we're going to the inside. Why are we going to table A? We need to find the corresponding z-score with it. Okay, so now what I'm going to do, the lower 10%, that's everything to the left, the lower 10%. So I'm going to find 0.10. 0.10 is approximately right here. The z-score that goes with it is negative 1.28. Okay, so I start on the inside, and I go see the z-score that corresponds with it, negative 1.28. So I filled that in. You can see that right there, negative 1.28. Now I need the z-score that goes with the upper 10%. Well, remember, your table only does the less than. This whole curve, the area under it equals 1. So if to the right of this purple line is 0.1, to the left of it is 0.9. Okay? So I'm going to go to my table, and I'm going to find 0.90. 0.9, again, going on the inside because I was given a percentage. 0.90 looks like it is closest to right here. That's a positive 1.28. So now what do I have? If you look at our summary from yesterday, I went to the table A, I went to the inside. Why? To get the z-scores. I have my picture with everything marked that was given to me. I go inside to the table, I find the corresponding z-score. Okay, so I scroll to the outside to get those z-scores. Now I'm going to use algebra with ZOMS to figure out the rest. Okay. So what am I going to do? You can see I have my z-score is equal to my observation, I don't know that, minus my mean, divided by my standard deviation. And I did it for this side as well. My z-score is equal to my observation minus my mean divided by my standard deviation. Okay, I figure out what my x is equal to. I'm going to let you guys finish it. Now in purple, when it asks what the decimals are in part A, that's your answer. I just wanted to know, can you go and use your table going backwards? So part A is just this part right here. Really making sure you understand part B. Rewind it if you need to. That's kind of the essential piece today. Okay, I want you guys to skip number 60 if you don't understand it. And 61 is really important. Okay, you really have this down if you can understand this. An airline flies the same route at the same time each day. The flight time varies according to the normal distribution with an unknown mean and standard deviation. On 15% of the days, the flight takes more than an hour. On 3% of the days, the flight lasts 75 minutes or more. Use this information to determine the mean and the standard deviation of the flight time distribution. I'm given percentages, okay? So when I'm given percentages, I know I'm probably going to do something like this. Picture table A, algebra, okay? There's just a little bit of a twist on this. So here's my picture. I have an unknown mean and an unknown standard deviation, but I know here's the minimum time a flight takes all the way to the maximum time. 15% of the days, the flight takes 60 minutes or more. So I put 0.15 with 60 minutes. Why did I choose an hour? Well, because I have 75 minutes there, so I want the same units. Now I'm going to draw a new curve. Same mean, same standard deviation, both unknown. It takes 3% of the time, it takes the flight 75 minutes or more. I can set up these two pictures. Next, I know I was given a percentage. So when I'm given a percentage, I can go to table A on the inside and find it and get the corresponding z-score. 15% is to the right. My table only does to the left, so the left of this green line is 0.85. I find 0.85 and I should get a z-score of 1.04. Again, 0.85, the closest one to it is right here. 0.8508, 1.04 is the corresponding z-score. Going back, 0.03. I can't find a z-score of 0.03 because the table only does to the left of this black line. So I go to 0.97 because this whole thing adds up to 1. I go to 0.97 on my chart. 0.97 is about right here. That's 1.88. I found my z-score. Okay, now I'm going to use algebra, ZOMS. I'm going to set everything up. I have 1.04 is equal to 60 minus an unknown mean and an unknown standard deviation. Again, on this side, 1.88 minus my observation of 75 minus my mean divided by my standard deviation. I have two equations. I have two unknowns. You are back in algebra 2. What I'm going to do is I'm going to solve for mean, my mu. It doesn't matter how you go about this, but that's just what I did. If you don't know how to solve for mu, I multiplied by my standard deviation. I subtracted 60, and then I divided by this negative to give me negative 1.04 standard deviation plus 60. Again, over here to solve for my mu, I multiplied each side by my standard deviation. I subtracted 75, and then I divided by my negative. I have two equations here. They are both set equal to mu, so I'm going to use substitution, meaning I know mu is this. So I'm going to substitute that over here. I'm going to set them equal to each other. Now we can set them equal to each other, and I'm going to have you do the rest. You can figure the rest out. I'm going to solve for my standard deviation. Once I've solved for my standard deviation, I'm going to plug it into one of these blue equations, evaluate, and that will give me my mean. If you need help with that algebra, just let me know during class individually, and I can sit down with you one-on-one. Thanks, guys, and hopefully you're having a great election day.